Welcome to Unit 2, the transport layer. The layer is the second in the TCP/IP model and the fourth in the OSI model. It is responsible for end-to-end communication between the hosts, ensuring messages are delivered reliably to the right destination process. Next, we see to the presentation overview. In this session, we will explore the transport layer step by step. First, we will understand the introduction and purpose within the TCP/IP model. Next, we will examine its core services like multiplexing and port addressing. Then we will dive into connection management, how connections are established and terminated. Finally, we will discuss error and flow control, which maintain reliable and efficient data transfer. Next, we see to the introduction to the transport layer. The transport layer acts as a bridge between the network and the application layers. It manages logical communication between the process on running on different hosts. Applications don't need to worry about routing or physical connectivity. The transport layer handles all of the behind the scenes. Its main goal is to deliver the data segment actually and order from the application process another. Next, we see about the key transport layer services. The transport layer provides the three key services. First, multiplexing and demultiplexing. They are allowing multiple applications to share a single network connection and direct incoming data to the right application using port numbers. Second, port addressing. It identifies the specific services like HTTP on port 80 or HTTPS on port 443. And third is the difference between the connection oriented and connectionless protocols. TCP is connection oriented to ensuring the delivery, while UDP connectionless it prioritizes to the speed and availability. Next, we see about to the TCP connection management. TCP uses the three-way handshake establishment connection. Step 1, the client sends a SON segment to intimate the communication. Step 2, the server replies to the SON and ACK. It means synchronization and acknowledgement to the process. Step 3, the client sends to the ACK confirming the connection. So ACK it mean to the acknowledgement. This ensures both slides are ready for the data transfer begins. Next, we see to the TCP connection termination. It is ending a TCP connection requires to the four-way handshake to ensure no data is lost. First, the sender sends a FIN to signal the has no more data. The receiver replies to the ACK. ACK means acknowledgement. Then send it into the own FIN. Finally, the sender sends to the ACK to confirm and connection closely and cleanly. Next, we should see about the ensuring data integrity and error control. TCP ensures data reliability through error control mechanisms. Checks and verify data integrity. Sequence numbers of helps to the reassemble segments in the correct order. Acknowledgement from confirmed receipt and retransmission record to the lost data. Together, these ensure accurate and reliable communication. Next, we see about the preventing and overload flow control. The flow control prevents to the sender from overwhelming the receiver. The TCP uses a sliding window protocol. The receiver advertised how much data it can handle, and the sender adjusts its rate accordingly. This balance maintains the smooth and efficient data flow. Next, we see about the TCP versus UDP. Let's compare TCP and UDP. TCP is connection oriented, reliable, and ordered. It is perfect for web browsing, email, and file transfers. Next, we see about the UDP. UDP is connectionless, faster, and simpler. It is used to gaming and video streaming and DNS lookup. The choice depends on the application need of the speed versus reliability. Next, we see the key takeaway and future outlook. To summarize, the transport layer enables the communication between applications. TCP offers reliability while UDP provides speed. As a technology evolves, New protocol aim to improve performance for 5G, IoT, the beyond. Next we see about the application layer in core protocol. Next we move to the application layer, the topmost layer of the networking. It provides to the interface between users and the network, the enabling application to send and receive data. Then we go to the journey through the application layer protocol. The application layer holds several essential protocols: HTTP for the web, DNS for the isolation, email protocols like SMT, SMTP and IMAP, and TCP for IP assignment, and P2P network for resource sharing. Then we go to the World Wide Web and HTTP. The World Wide Web allows to the global access to information powered by HTTP, the protocol that defines how browsers are and serves the exchange data. HTTP ensures the constant communication and responses across the all web interaction. Next we see about to the DNS. It means domain name system. DNS acts like a internet phone book. It translates domain name into IP address. When you type website name, your browser sends a DNS query, and DNS resolves to find the matching IP address and allowing to device to connect. Next we see to email protocol. First we see to the SMTP and IMAP and POP3. Email communication relies on multiple protocols. SMT sends an email. IMP allow access and manage the message on the server. And POP3 downloads email into single device. Together they ensure the smooth email delivery and access. Next we see to the dynamic host configuration protocol. It means a DHCP. DHCP automatically assigns IP addresses and network parameters to devices. It simplifies the network management and prevents a conflict by ensuring every device get a valid and unique configuration. Next we see to the P2P networks. It means peer-to-peer. In P2P networks, every device can act both client and server. This is decentralized design enables to direct sharing of data, storage and computing power, often using a file sharing a blockchain systems. Next we see the ARP and RARP. ARP maps IP address to the physical MAC address, enabling direct device communications within a network. RARP now mostly replaced by the DHCP. Once allow the device to request their IP using only their MAC address. Next to the interplay of protocol. All these protocols work together seamlessly. The HTTP for browsing, DNS for name registration, DHCP for IP configuration, and SMTP or IMAP for emails. Each plays the vital role in the overall function of the internet. Next we go to the key takeaways and next steps. To warm up the application layer protocol powers everything we do online, from browsing and email to dynamic networking and sharing. As a network involved, understanding these protocols help us design more efficient and secure communication system.